All right, so I wanted to do a quick video on logarithms part 4. All right, we're going to finish this up, this series. This is the last in the series. And basically on this one, we've got if log base 4 of 3 is about 0.7925, and we're going to use that to approximate the value of log base 4 of 192. I don't know if you can see that well, but log base 4 of 192. So to do this, we're going to need the product rule for logarithms. And the product rule is simply log base, b of a times c equals log base b of a plus log base b of c. And we're not going to get into it too deep, but that's what it is. Basically, if you have two numbers that are multiplied together, you can break them up into a sum. Okay? And so what does that have to do with this problem? Well, let's think about it. 192 can be broken up into, let's see, obviously, when in doubt, go with 2, right? 2 and, let's see here, 96, which 96 is 12 and 8, which gets us to, let's see, this is 4, 4 and 3, this is going to be 2. Okay, so basically what we got here, if we had log base 4, 192, I can regroup this to think about it in terms of, okay, I got a 4, and then these 2's together make a 4. So I got 3 4s basically. So I've got log base 4 of 4 cubed, right? Because I got 3 of them. So 1, 2, and then these 2 together is 1, times, and then what's left? Well, this 3 right here. Okay. So from that, I can say, oh, okay, all right. Well, I got log base 4 of, let me put this in parentheses. Now I know by this, I can break this up into a sum. I can break this product up into a sum. And so to do that, I'm going to have log base 4 4/3 plus log base 4 of 3. Okay. Well, the beautiful thing about this is since I have base 4 and I have 4, the exponent is what I'm trying to find the product of. These 4's basically cancel, and I'm left with 3. So you end up with 3 plus log base 4 of 3. Well, we're told to use this to approximate that. So plus 0.7925. So the answer is 3.792. Just like that. And that's it. That's all I have to do. All right. So we've got that. Let's take a look at this next problem. All right, the formula for pH is given by pH equals log base 10 of 1 over hydrogen plus, which is a hydrogen atom, hydrogen plus ion, right? This is a hydrogen atom that has lost its electron, which most of them have. Find hydrogen plus if the pH level is 4.2. All right, so let me kind of rephrase this problem. We're basically given this formula, pH equals log 10 1 over. And what we're going to have to do here is solve for H plus, and then we're going to replace it with pH is 4.2. All right, but to do this, we're going to need another logarithm, I guess, identity, if you will. And basically, it's this, that if you have log base b of a over c, This is the same thing as log base b of a minus log base b of c. All right, so in other words, the quotient rules, you subtract, if you have one thing over the other, you subtract the numerator from the denominator. So what we're going to do now is we're going to say, okay, all right, well, what can I do? I can break this up, and I'm just going to go ahead and fill in the blanks here. We're going to take pH as 4.2, so I'm going to take that and replace it with 4.2. So we're going to have 4.2 equals, now I'm going to take this using this rule, and I'm going to say log base 10 of 1 minus log base 10 of my hydrogen plus atom. All right. Now, log base anything of 1 is 0, right? Because remember, way back when, like 2 to the 0 is 1, 12 to the 0 is 1, anything to the 0 power is 1. Therefore, if I rewrote it as a logarithm, I'd have like log base 2 of 1 equals 0, log base 12 of 1 equals 0. So anytime you see 1 pop up here, the answer is 0, right? So once again, we got log base 10 of 1, so that's 0. We got 4.2 equals 0 minus log base 10 of my hydrogen plus atom. I can then, since this is a 0, it's basically just negative log base 10 of hydrogen plus atom, and I could multiply both sides by negative 1, which gives me negative 4.2 equals log base 10 of my hydrogen plus, whatever that is going to be. Then the beautiful thing about this is I can now multiply both sides by 10, or take both sides to the 10th power, which gets rid of the log on this side. So that gives me 10 that gives me 10 to the negative 4.2 equals what my hydrogen plus is. And of course, we can put that, in our calculator. We can think about it. We can say, let's see. So we've got 10 to the caret negative 4.2. And it gives us 0.006, this thing right here, right? So let's see. Sig figs will say 1, 2, 3, 4, and then 5. So it'll be what? 6.3 times 10 to the negative 5. And that's going to be our answer. Okay. All right. So that's how you do that. I'm going to try to be a little, excuse me. I'm going to try to be a little bit quicker on these last couple of videos. Let's see. So we got log base 3 of 5 equals, and then we're going to approximate log base 2 of 25. Now for this, we're going to need the identity. If you have, like, say, I don't know, log base 4 of 4 squared. Now we already know that's going to be 2, but let's think about it for a second. Another way we can do it is what I've heard some teachers, I didn't make this up myself, but I heard a teacher call it chopping the log. In other words, if you have an exponent up here, all you have to do is take that and put it on the outside of your logarithm. So this ends up being 2 log base 4 of 4. Of course, log base 4 of 4 is just 1, so that's then just 2. Does that make sense? So this is what we call chopping the log. All right. So if we have log base 2 of 25, okay, we know 25 is 5 squared, so we can say log base 2 of 5 squared. We can then chop the log and say 2 times log base 2 of 5. Now we already know what log base 2 of 5 is, right? We know log base 2 of 5 approximately is about 2.3129, right? So we can say that's about 2 times 2.3219, which is about, let's see here, that's about 2.3219. It's about 4.6430. So it's about 4.643, not 0, but 8. And that's it. All right. Pause the tape, see if you can figure out this problem, given if log base 3 of 7 is about 1.77212, find log base 3 of 49. Okay? And make sure you put your answers in the comments. All right. Last but not least, we've got an equation kind of using a little bit of everything that we've learned thus far. All right, so according to that product rule that we learned, right, I have two logarithms that, they're a sum. That means it's the product of their insides. So this is really just log base 6 of x times x minus 9 equals 2. All right, now from that, we can multiply this x out on the inside here, which gives us log base 6 of x squared minus 9x equals 2. Now, what can I do with that? Well, what if I take both sides to the 6th power? Okay, or I have the base of both sides that's going to be 6. So basically, do like this. Okay, what that gives me is obviously the log and the 6, they cancel each other out. And you'll be left with x squared minus 9x equals 6 squared. This right here gives us x squared minus 9x equals 36. And now I want to do some really quick factoring. Once again, it's quadratic, so you bring everything to one side. That gives us x squared minus 9x minus 36 equals 0. If I try to find two numbers that multiply to give you negative 36, but add to give you negative 9, that's going to be x minus 12 and x plus 3. So I've got two answer choices, x equals negative 3 or x equals positive 12. Now, because I've got two answer choices, I got to determine which one's correct. They might both be correct, but let's find out. The most easiest way to do it is think about it like this. If I take this negative 3 and I put it into this equation, I'll end up with log base 6 of negative 3. We already know you can't have a negative be something that you're taking a log of, right? That can't be the result. Your result can't be a negative number. So negative 3 is out. So let's try log base, let's try submitting 12 and see if it works. So we end up with log base 6, 12 plus log base 6 of 12 minus 9 equals 2. Let's see if this is correct. Basically, if I multiply these two together, I know log base 6 of 12 times 12 minus 9 is 3 equals 2. Log base 6 of 36 equals 2. And we know that indeed is correct. All right, last problem. We got solve log base 6 of x plus log base 6 of x plus 5 equals 2. Let me know in the comments whether you think it's I, J, K, or L. I'll see you guys in the next video. Don't forget to like, subscribe, hit the notification bell, do all the things, and I will see you guys in the next video.